In this lesson, we're going to go through tangent function graphs. Okay, so the general form of a tangent function is really similar to a sine and cosine graph, but there's a couple of subtle differences. So A is still our dilation, N is our period. Now the period in a tangent function is actually not 2 pi over n, which I was about to write. It's actually pi over n. And what that means is the length of it when it repeats is actually not as far as sine and cos. And then h for horizontal shift, and k for the vertical shift. Okay, now you might notice that in a tangent graph, so this graph that I have here is tan of x. In a tangent graph, there's actually an asymptote. Now, remember tan of x is equal to sine of x over cos of x. For that reason, you might notice that that cannot be equal to 0. So whenever cos of x is equal to 0, it's an asymptote. So just keep that in mind because we need to use that to find stuff later on. Alright, so if we're sketching the graph of tan of x from negative 3 pi over 2 to pi over 2, then first of all set an axis, and then start from the front. Now if you remember, each period for this one is pi over 1, so it's a pi. So it starts from 0, goes all the way up to pi, and then it stops there. Then, if you remember the shape, it joins together here. That doesn't look very nice. So that's x equals to negative pi over 2. Starts from the top again. Now remember a period is pi, so it goes from 0 to pi there. So that's one cycle. Then the next one is pi away, so that's x equals to negative 3 pi over 2. Oh, don't know what happened there. Alright, on the same diagram, sketch the graphs of y equals to tan of x and y equals negative 2 tan of x. So what I will do is I will draw them, but then, so I'll draw y equals to tan of x first, and then I'll put in negative 2 tan of x in a different color. So I'll use black for this one, and I'll use orange for this one. Alright, so y equals to tan of x. We start from 0, going up, this goes to pi on 2, and then on the back it goes to negative pi over 2. Alright, so now the orange one. So, notice that we now have a reflection and a dilation, so that means it's going to rise a lot sharper. And it's also going to, what do you call it? Have a reflection, so it's going to go the other way. So it's going to rise a lot sharper. That's not sharper, actually. Alright, it rises up quicker, so it'll go up like that, and like that. So the black one is y equals to tan of x, orange one is y equals to negative 2 tan of x. Alright, so now on the next one, sketch the graph of y equals to tan x minus root 3. So that means it's now shifted down by root 3. So now our x-intercepts aren't going to be the same, so maybe we should firstly work that out. Now, as you can see from the first one, we'll just have one intercept anyway. So we just simply need to work out the first one. So tan of x minus root 3 equals 0. So we have tan of x equals the square root of 3. And it's equal to square root of 3 when you have pi on 3. So, sketch a graph as you have before, but show that it's shifted down. And then it'll cross over at 0 still. Oh, sorry, it'll cross over at when x is 0, but when y is equal to negative root 3, because it's shifted down by root 3. And it goes up to pi over 3 when it crosses. That is not very straight. Try that again. Okay, sketch a graph of y equals a tan of 4x. So, as before, we need to find out x-intercepts first, and we also have to do that via finding the implied domain. So, if you look at the implied domain, we just multiply each of these by 4, so we have to solve all the way up to 4 pi. So then what we can do, find out x-intercepts. We want when it's equal to 0. It's equal to 0 at every pi, so we have 4x equals to 0, pi, 2 pi, 3 pi, and 4 pi. Then divide each one of those by 4. Oh, almost wrote 2 pi over 4, pi over 2, 3 pi over 2, and then pi. Okay, now we need to find when it's undefined. Now you have to think about when, for tan of x being undefined, that's when so remember tan is sine of 4x over cos, tan of 4x is equal to sine of 4x over cos of 4x. So we want to find when this is undefined. Now, if you think about it, you can't divide by 0, so that's when it must be undefined. So in other words, we want when cos of 4x is equal to 0. So then cos is equal to 0 when it's every pi on 2. So we have whenever you have pi on 2. So pi on 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So then divide each one of these by 4. I did not divide each one of these by 4. I divided them by 2. Sorry. So 8, 8, 8, 8. Better. Okay, now let's draw it. Make sure you leave plenty of space, as you saw before. Right. My suggestion is always put the asymptotes in first. That way your graph is always going to line up nicely. Like so. Then start drawing. Now put in your intercepts. Oh, made a mistake there. That's divided into 4, so 3 pi over 4, and then that's a pi. Alright, sketch a graph of y equals the y equals the tan of x plus pi on 4. So now we have a shift, so now we have to work out how far each thing has shifted. So, if you look at our period, we have pi over 1 still, so it's still a pi. Because this is going up to 2 pi, we'll have 2 cycles that we'll be drawing in. However, it's shifted, so we have to think about how far this has shifted. So, firstly, find your endpoint. And this will pretty much tell you which way it shifted. If you get a negative value, you're going to have the negative part, so the lower part. That's how far it shifted. But usually, well, I won't say usually, but quite often you will have a positive part. That shouldn't say endpoint, that should say y-intercept actually. Alright, so y-intercept when x is equal to 0, so put in 0. Y of tan of pi over 4 is equal to 1. So we actually start at 0, 1. Then now we find the endpoint, which is at 2 pi. Two pi is just one cycle. In other words, we've just gone back to our starting point, so it's still at a 1. So just keep in mind that's where we're going to end it. Then find our x-intercepts. When y is 0. Oh, sorry, missed a step. Let's find our implied domain first. Okay, so we have to add pi on 4 to each one. I almost wrote the wrong number. 9 pi over 4. Alright, from here we can now solve for our x-intercepts. So y is equal to 0. Nothing too tricky, we just want the ones where it's equal to 0, so same thing as before, it's at every pi. So we have x plus pi over 4 equals to 0. Oh sorry, 0 is actually not one of the solutions because of that. So the next one, pi, 2 pi, 3 pi, and 4 pi. 4 pi? No, too far. 2 pi. Then we just simply shift it back by minusing pi on 4 to each. So we get 3 pi over 4, and then 7 pi over 4. Alright, now to find the asymptotes. So remember that's when cos of whatever that is equal to 0. It's equal to 0 if you have every pi on 2 for anything, sorry, for the top and the bottom. So yeah, pi on 2, 3 pi over 2. If I can write, that would be great. Then we just subtract each one by pi on 4. So it's 4, 6, so 6, so 5 pi over 4. Okay. Now let's sketch it in. So remember, put in your intercepts first, your asymptotes first. So proportional, that's better. Now we're starting at 1. Put in our x-intercept. And then we end at 2 pi and 1. Okay, so state the transformations for y of tan of x to what they have there. Now remember, as of before, always factorize what's inside the brackets. So we have tan of pi over 5 x minus a half. Then let's write down what we have. So we have a horizontal shift of a half to the right. And we also have a dilation of 5 over pi from the y-axis, or if you like, parallel to the x-axis. Okay, 2. State the period of a function from that. So our period is equal to pi over n. Now n in this case is pi over 5. So pi divided by pi over 5 gives us pi times 5 over pi, which is in a 5. So our period in this case is a 5.